Alrighty, this is AspectJ. My name is Ryan McGrath. Today is May 4th, 2022, and this is my final project, so let's just jump right into it. Alright, so AspectJ is an aspect-oriented programming language. It was first introduced in 2001 by the Eclipse organization. It has become the industry standard for aspect-oriented languages. It was initially designed to address some core features in which the standard Java library didn't have at the time. We'll go more into depth on some of that later in the presentation. However, some of the main concepts that I wanted to talk about are modularity, the verticality versus horizontality of aspect-oriented programming as opposed to object-oriented programming, some of the abstraction that comes along with the language, and the cross-cutting functionality. When designing AspectJ, the developers were very concerned with the business costs of onboarding new technologies, including some of the costs associated with training and potentially replacing existing tool chains for developers. So that was at the forefront when designing AspectJ. When it was introduced, AspectJ solved this issue by running as an extension of Java with the goal of being compatible with all current and future versions of Java. So let's talk about some more of those core ideas. So really at its core, AspectJ primarily offers four new things. The first of which being the aspect. The aspect, which Baldung provides this definition, is a modularization of a concern that cuts across multiple objects. Each aspect focuses on a specific cross-cutting functionality. Then you have the join point, a point during the execution of a script, such as the execution of a method or property access. The point cut, a regular expression that matches join points. And lastly, the advice, which is action taken by an aspect at a particular join point. So what does that really mean in layman's terms? You can really think of the aspect in the same way that the object is to object-oriented programming. The aspect is really at the very center of what makes AspectJ a different language structure compared to object-oriented programming, and we'll get into that a little bit more later in the presentation. You can also think of the join point as really just a point during the execution that the instructions have been gathered and are set to be executed. And you can see that in the two diagrams that I have off to the right side here, particularly in the bottom one down here. You can see that the join points are all collected at the point cut, and at which point the program is executed. And lastly, we have the we have the point cut. Now the point cut, you can visualize this in your head, similar to how Java has methods. AspectJ uses point cuts to gather various join points to then execute them. And then lastly, we have the advice. Advice is a unique term. You can really think of the advice in AspectJ more so like a conditional in Java. The advice is used in this situation and is the action taken by the aspect. So let's talk about some of the primary advantages to why you would really want to use AspectJ. So when working with a large code base, it's very easy to have various design elements stretched across several code locations. This occurs as the scope of the project expands or the complexity evolves as new ideas are implemented. Object-oriented programming can be viewed in a top-down like structure as seen in the graphic off to the right. Up top, we have the code base prior to AspectJ being implemented. And on the bottom, it shows as those lines, which are highlighted in orange, are then collected, they are modularized, and they're placed in a single location. Let's take a look here. If a change or revision needs to occur, the changing of the entirety of the code base can be not only done in a single location, but without aspect-oriented programming, it can be both financially costly and also from a time perspective. Additionally, with large changes like this, it brings a very real possibility of unwanted behavior or bugs. AspectJ offers the ability to collect this code in a single location, as I had mentioned, without directly entering into the flow of the underlying code. This is really huge because not only does it allow the user to make changes to the code on a large scale, but it also allows them to safely modify the behavior of the code without the risk of accidentally breaking the underlying code base. AspectJ also works in a sense like metadata, using code, the underlying software, as the basis for its data. So in this situation, as I had mentioned before, the top image demonstrates a pre-existing code base, and when AspectJ is then introduced, it then runs similar to metadata, in which it collects information about existing software and is able to make determinations based off user input to make changes that are desired. What's very nice about this is it does not directly inject itself into the underlying code, but we will see later how it can be implemented to either interact intermittently, in between, before, or after. So now that we've talked a little bit about this, let's talk about a real-world example where you would really want to use this. So these are just a handful of cases in which AspectJ can be used, not only to manage those large code systems, but also mitigate the possibility for breaks on the production. So one of the biggest attractions comes from the security and logging side of the picture. I want you to imagine for a moment that you work at a large company and all the staff are connected to an internal network. So you can think of this as maybe your Google, your Facebook. It doesn't necessarily have to be something that large, but typically a large organization. This company houses a lot of documents, proprietary information. Not everyone has the same job, and not everyone has the same privilege levels. So the tech team is tasked with stratifying the network so that, depending on your position, you have certain access levels, which is a fairly standard practice these days. So great. They decide to use some constructors so that as new people are hired, they can easily stamp out new people into the network with different access levels based off, what your job description is and what your needs are. Now imagine that the company has a data breach and they've decided to restructure the access levels in the company to reduce the risk of another attack. Okay. How do you implement this without visiting each member and changing their roles? You've already created all these instances, you've added them to the network. It'd be very costly from a time perspective to reverse all this, and there's also the very real possibility of human error producing some unwanted features. AspectJ can do this very easily due to its ability to not only cut across the system, as I had mentioned earlier, but also ignore typing altogether. What do I mean by this? I'll show you in just a little bit once we get into a demonstration. For now, this is just one example of how this technology can be implemented to solve real business problems. So let's actually take a look at how this technology is implemented in real time. So I have here, and hopefully this picks this up, I have here a little Java class that I put together. In it we have method 1, in which it prints out hello. It does not have any parameters, and in the second one we have another method called method 1, and in this one it takes in the parameter name of type string. Now in Java, this is a classic case of method overloading, in which multiple methods can share the same name, however they have different parameters. In this situation, the second method 1 will print out hello, then the string passed into the method, and then it will print hello again. And lastly, we have method 2 down here, which also takes in a string and will print out the second method parameter is, and then the parameter. So up at the top, we create a little object, and we will run this very briefly to check some of the output on it. And down here we see we have the desired output. This prints hello. The second one prints hello, Ryan being the parameter passed in, and then it says hello again. And then lastly, we have method 2, which prints out the second method parameter being the graph. So this would be a classic example of method overloading in Java. So let's talk about how AspectJ can be used to introduce some additional functionality. So over here, I've also created another AspectJ piece of code for this presentation. I'm going to leave this bottom part commented out for the time being. But for now, all I want you to do is focus on this up here. So in this first point cut right here, what we're doing is we're making a call to the AOP demo right here. This organization name is the package that both of these are associated with, so you can largely ignore this. However, what this is saying is I want you to make a call out in the code base for any AOP object that makes the method call of method 1. And what this asterisk here means is you can ignore any of the parameters. So let's take a look at that, and we will come back into here, and I will run this once again with that turned on. I'm sorry, this tells it to run after the first method. So here we say it will print aspect after, and that is due to the after reserved word, meaning after this is called and compiled, we want to print this out. And as you can see down here, hello, Ryan, hello, aspect after is printed. Once I come back in here, I'll uncomment this so you can see this as well. What this is going to say is upon runtime, we want to print out before any of these are called the before aspect. So if I come back in here and I rerun this once again, we'll see that it is run before the method call. So this is just a brief demonstration of how aspect-oriented programming, or AspectJ in this situation, can be used to enter the code base at any time. If I were to come back in here and recomment all of this out, you'll notice that if I were to run this once again, that the underlying code is not affected at all. It doesn't break, it doesn't throw any warnings, and that's because this runs as an extension at runtime as opposed to having been manually entered into the code base. One of the other things I'm sure you've probably noticed at this point is that syntactically, AspectJ and Java share a lot of similarities. This was done intentionally. As I mentioned before, developers were very concerned about the cost of implementing this new technology, so they wanted to make the onboarding process really as seamless and as easy as possible to allow developers to quickly implement this with as little confusion as possible. And then lastly, what we have down here is my final point cut. And what this is going to do is this will say, I want you to look for all method calls of the method 1. And after that, I want you to, after that, we have our greeting function right here. I want you to print out world. So now that I've uncommented this, if I come back in here, I'll run this once more. And you'll see, and I will briefly clean this up for you so that it's a little bit easier to read when it's coming out. And we'll run this again. We'll see that after the first method is called hello, we see world, and then the second method, which is hello, the parameter name, and hello again, also prints out world. Now this is a prime example going back to you work at a company in which the security needs change, where they may ask you to collect all of the data or all the instances of the employees on the network and make some variations to their access levels, and this is primarily how it would be done. This could either be done before, after, or during execution. AspectJ offers a lot of flexibility in that. And in this situation, it was a very simple print. However, it also allows for data manipulation and a bunch of other features in which you can manipulate the underlying data. So now that we've taken a look at how this is directly implemented, let's go back to the slide and we'll take a look at lastly, how does this technology really fit in today? So as I had mentioned earlier in the video, AspectJ was originally introduced in 2001, and a lot has changed since then. Usability, well, we'll start with some of the strengths first. Primarily, usability and ease of implementation have really remained at the forefront in terms of what makes this language attractive. It's still very safe to implement and still runs on top of Java, making it very easy to bring into existing code bases with relative certainty that the underlying code will not be affected, and it should be fairly easy to directly implement into whatever project that you're working on. Additionally, it's a very powerful tool, as we had seen before with those intertype declarations, where you did not have to specify parameter names. You also don't have to specify returning types. It can collect all of the different method calls. This is particularly useful going back to the situation I had mentioned before, in which there might be a large degree of variation, and going through and nitpicking all the different instances or different use cases could be incredibly time ineffective. This is where this tool really starts to shine. Lastly, we have greater flexibility in managing execution. Additional flexibility and additional control over the code is always going to be a plus. I'll talk about that a little bit more on the weaknesses side. So let's just jump right into the weaknesses. So sadly, new technologies like Lombok, which we see up here, have kind of diminished the value of some of the core features of AspectJ. Lombok handles much of the boilerplate code associated with large code bases. It can automatically handle large changes. It manually, upon creation of a lot of projects, will handle the getters and setters. It will handle, as we see in that picture over there, no argument constructors, all argument constructors. It has really been developed to kind of address some of the main features that AspectJ offers without some of the drawbacks that are associated with it. And we're going to talk a little bit more about that down here. So as I had mentioned before, it's a very powerful tool, both for a developer and also potentially for a hacker. Cybersecurity is at an all-time high right now, and technologies like Log4j, which were just recently in the news, are a perfect example of how hyper-pervasive pieces of software can really turn a nice feature into a massive vulnerability. While AspectJ's ability to cut across code bases indiscriminately and both not only extract but potentially inject code into a code system is nice from a standard of living perspective, it also poses a massive risk in terms of companies that cannot afford data breaches. Off the top of my head, I'm looking at healthcare systems, any legal systems, really any company that handles proprietary information, proprietary data. This can be a major turnoff, and it's the main reason why these companies have started to turn to things like Lombok in terms of modularizing some of their individual needs that they might have. And lastly, we come to JUnit, Mockito, and unit testing. So if you're not familiar with those, unit testing is a practice not only in Java but in many other languages in which code is routinely checked for code coverage in terms of how much of the code is being reached, and it allows the developers to routinely stress test their code to ensure that any variations in input are being covered and that clean, consistent code is being produced and contributed towards. While pre, post, and during manipulation are very useful, there are a lot of newer technologies, these just being a few, that really have started to phase out the value of it. Better business practices have also been a big killer. I know that unit testing and the word is escaping me right now, agile testing, there it is, has really begun to phase out some of this, and some of these technologies like Mockito and JUnit have unfortunately started to wane on the value of AspectJ. In my personal opinion, AspectJ still retains a lot of its value to a certain degree. However, alongside a lot of other technologies, time is usually not on their side and tends to be the killer. AspectJ was introduced in 2001. It's 2022. It's been 21 years. It's had a fantastic run, but I think as time goes on and we see more technologies act as microservices for Java, its use case is going to continue to diminish. This has been my project. Thank you much for your time this semester. I will see you at the final. Take care.